Good afternoon, everyone. I am Mr. Ish. Let's take a brief break from calculus topic and come to this trigonometric topic, that of cofunction identities. Cofunction identities are those identities which define the relationship between angles, complementary angles, and the trigonometric functions. You know what a complementary angle concept is. Sum of two angles that equal 90 degrees are complementary angles. Any two angles that add up to a total of 90 degrees are complementary. If you have a right triangle, the other two angles are complementary because their total sum will equal 90 degrees. You know there are 6 cofunction identities which relate the 6 trigonometric functions. In this video, we don't want to be monotonous in the sense that we want to look at just the 6 cofunction identities and just merely state what the formulas are. We want to look at how the formulas come about, the derivation of those formulas. In a very layman's sense, if you draw a right triangle, you know this other angle over here is complementary to that theta, and it must be 90 minus theta. If you label this A, this B, and C, and you put your I right over here on this angle, and you define this angle in terms of cosine, what do you get? Cosine theta is equal to A over C. Right? Cosine theta is equal to adjacent over hypotenuse. Now next, if you put your I over here and you define with regards to that angle the same relationship, what do? You do sine, and that angle being 90 minus theta is equal to opposite. With regards to this angle, the opposite is A and the hypotenuse is C, A over C. If cosine theta is equal to A over C and sine 90 minus theta is equal to A over C, and both of these are equal to each other, then you know cosine theta is equal to sine 90 minus theta, which is a cofunction identity. The cosine of an angle is equal to the sine of its complement. If you look back at this angle here and start defining everything in terms of B, then we can say sine theta is based on this angle. Theta is opposite over hypotenuse. If you look here again at this angle and start defining everything in terms of B and C, then you must say cosine of the 90 minus theta, which is complement to that, must be equal to adjacent with regards to this angle right here, adjacent over hypotenuse. And here B or C equal each other. These two expressions equal each other. Your sine theta is equal to cosine 90 minus theta. So in a very layman's sense, you can show these identities, which are indeed cofunction identities. The sine of an angle is cosine of a complement. The cosine of an angle is the sine of its complement. And that's just looking at things in a layman's perspective. Let's look at things in a more formalized sense in the remainder of this video. The cofunction trigonometric identities also show or relate the graphs, in that the cofunction identity says that the sine and the cosine graphs are identical except for a pi over 2 shift. And you know, pi over 2 represents the sum of two complementary angles. Apart from the shift, that 90 degree shift, both the sine and the cosine graphs are identical, and likewise their reciprocals, cosecant and secant, are as well identical except for that 90 degree shift. If you look at just a single sine curve, it would look something like this. But if you look at a cosine curve, you know, here's pi over 2 and 3 pi over 2, the cosine curve would look something like this. If you look at this point right over here on top of the sine curve and this point right here on top of the cosine curve, the difference between these two will be a pi over 2, and that's the pi over 2 shift. The result of one curve being 90 degrees ahead or behind the other, and pi over 2 is a complement in terms of the sum of two complementary angles equals pi over 2. If you just look at this opposite end and you draw, here's my cosine curve, and you draw a secant function right over here, and you draw a cosecant function right here, aiming downwards of course from the sine curve. Again, these two are 90 degrees apart. From right here to here, there's 90 degree shift. So the sine, cosine, and the secant and the cosecant are identical except for this 90 degree shift. The tangent and the cotangent are not identical, but they indeed also have this shift. Here's a tan curve, which you know, pi over 2 and minus pi over 2 in the vertical asymptotes, and it looks something like this. That's tan x. And then let's draw cotan x. In the cotan x, you have 0 and pi serving as a vertical asymptote, and the curve looks something like this. But if you look at this point right over here, this intersection point, and you look at this point right over here, and this right here is my cotan x, and you look at this intersection point over here, the intersection point on tan x is a 0, the intersection point over here on cotan x is a pi over 2, and again these two points are pi over 2 degrees apart, so there's a pi over 2 shift which you're seeing in all of these functions. The sine and the cosine have a pi over 2 shift, the secant and the cosecant have a pi over 2 shift, and the tan and the cotan have a pi over 2 shift. Just an interesting fact. We will look at the derivation of these 6 cofunction identities in the remainder of this video. Let's look at the first 2 cofunction identities, the ones which relate the sine and the cosine, and they very well depend on the difference formula for sine and cosine. If you look at sine 90 minus x, you're thinking about the sine x minus y, and you know you have to use a difference formula. You'll have, with regards to 90 and x, we have to use those. We won't use x and y. Let's go right over here. Right over here. We'll have sine 90 cosine x minus sine x cosine 90. You gotta just simplify this. Cosine 90 is 0, it zeroes everything out. Sine 90 is a 1 times cosine x, and you get cosine x. So we know that sine 90 minus x must equal cosine x. Sine of an angle or sine of a complement is equal to cosine of the original angle. Let's come down over here to the cosine cofunction identity. It has to follow the format of the cosine difference formula. You know what this is. You plug in these and what do you get? You get cosine 90 cosine x plus cosine 90 cosine x plus sine 90 sine x. Cosine 90 is a 0. This zeroes everything out here. Sine 90 is a 1. You get 1 times sine x. And your final answer is sine x. So sine x is equal to cosine of its complement. Cosine x is equal to sine of the complement. And you can do similar derivations for the other cofunction identities which we'll look at. Now the tan and the cotan are related to one another. And you don't want to break these down using the tangent and cotangent difference and sum formulas. You want to do everything with regards and with relation to the sine and the cosine. If you're looking at tan 90 minus x, you can think of everything as sine 90 minus x over cosine 90 minus x. And when you think back to the previous formula, right, the previous image derivation, sine 90 minus x, you know was equal to cosine x. And you know cosine 90 minus x was equal to sine x. And when you think back to the definition of trigonometric functions, cosine or sine is equal to what? Cotan x. Therefore, tan 90 minus x is equal to cotangent of x, or you can say cotan of an angle is equal to tangent of its complement. You can do a similar procedure here for the cotangent. Think about everything in terms of sine and cosines. Cotangent 90 minus x would be looking at cosine 90 minus x, and then divided by sine 90 minus x. We already know cosine 90 minus x, cosine of an angle is equal to sine of its complement. You can read it that way. And sine of an angle is equal to cosine of its complement. And you know sine x over cosine x is equal to tan x, which goes on to show that the tan of an angle is equal to cotangent of its complement. So in the previous image we saw that the sine and the cosine were related by means of complementary angles. But here we see that the tangent and the cotangent are related by means of complementary angles. Then therefore by default secant and cosecant will be related by means of the relationship between complementary angles, and that we will see next. As is always the case, always try to look at things from the basic perspective and using the easier functions. Here the easier functions will be think of everything in terms of sine or cosine. You know secant is a reciprocal of cosine, therefore think of everything here in regards to cosine. You'll have 1 over cosine 90 minus x, and you know cosine of 90 minus x is equal to 1 over sine x. Reciprocal of this sine x must be cosecant x. So let's say the cosecant of an angle is equal to secant of its complement. Now look over here on the bottom, cosecant of 90 minus x, break it down into its easier function. Cosecant reciprocal is sine. But we know that the sine of an angle is equal to cosine of its complement, so we can replace 90 minus x sine of that with cosine x, and you know cosine x reciprocal is secant x. So the secant of an angle is equal to cosecant of its complement, and then now you see over here that cosecant is related to secant by means of complementary angles. It would be so much easier to look at everything here with regards to sine and the cosine versus looking at things in a more different or more difficult perspective. Everything as always breaks down into sine and cosine, where and when possible you should be using that. For the closure of this video, I'm just going to go on and say this, that the cofunction identities, the usefulness of those identities is enhanced by you all remembering the trigonometric ratios. Remember, you know the 30, 60 and 90 triangle, you have the 1, 2 and root 3 ratios which arise, and then you know there's a 45, 45 and a 90 triangle. the isosceles triangle, isosceles right triangle. These have the 1, 1, root 2. So if you have a question which involves cofunction identities, just knowing these trigonometric ratios with regards to those cofunction identities serves as an excellent shortcut, especially when you don't have a calculator. If you were tasked with finding what's tan of 60 degrees, if you didn't know this off the top of your head, you could think of it in terms of this. You're looking at something like sine of 60 or cosine of 60. Thinking back just to the ratio sine of 60 is this. Here's your angle 60, and you're looking at, with regards to this tan, 60 would be, sine of that would be root 3 over 2. When you're looking at 60 in terms of its cosine, it's 1 over 2. And then when you simplify this, you just get root 3. Another way you can think about tan 60 is also, as you know, cotan of 90 minus 60, which would be cotan of 30, right? What's cotangent with regards to 30? It will be adjacent or hypotenuse, and it will be root 3. This does not necessarily mean that these are only the defining ways by which you can use the cofunction identities, but the cofunction identities along with the trigonometric ratios adds to the benefit of you all knowing those identities, because these trigonometric ratios greatly simplify procedures, trigonometric calculations, and you don't even need a calculator. We'll keep this video short. Thank you for watching. Have a great day. Bye.